All right, welcome to The Explainer. Seriously, I am so thrilled to have you here today. If you're currently studying for the Cambridge AS and A-Level Computer Science 9618 exams, well, you've landed in the exact right place. We are going to dive straight into this. Today, we're going completely under the hood to really master one of the absolute most critical topics on the entire syllabus. We're talking about normalization. Specifically, we're zooming in on second normal form, or 2NF. And look, we aren't just going to rehash what it is. You probably already have a textbook for that. Instead, we're going to break down the exact step-by-step strategy you need to actually conquer the exam questions on it, because knowing it and scoring marks on it are two totally different things. Okay, take a look at this quote. Mastering normalization, second normal form is essential. This topic appears in every examination series. I really want to emphasize that word, every. This isn't one of those niche topics that might, maybe show up if you're unlucky. No, it is a guaranteed, heavy-hitting cornerstone of the exam. The examiners are basically waiting with red pens to see if you can successfully resolve those partial dependencies. And honestly, if you want a top grade, you literally cannot afford to ignore 2NF. It's a fundamental requirement. You just have to know it. So, here's our roadmap for today's session. First, we'll tackle the 2NF exam challenge to see exactly why resolving these database dependencies trips up so many otherwise brilliant candidates. Then, we'll move into the core principles and theory. After that, we'll break down the standardized procedural framework, which is basically a cheat code, before looking at the top 3 examiner warnings straight from the grading floor. And finally, we'll wrap up with the ultimate method mark strategy. This structure is basically us taking a direct look right into the examiner's playbook. Let's kick things off with Section 1, the 2NF exam challenge. We really need to start by just acknowledging the reality of the situation here. This subject matter is inherently difficult. The assessment isn't trying to go easy on you. It's deliberately designed to push your cognitive limits. It is absolutely not just about rote memorization. It's about highly specific, on-the-spot application. You see, multi-step calculations and capturing those elusive method marks consistently challenge Cambridge candidates. The crucial point I want to make here is that the difficulty isn't just in knowing the basic facts, right? Like knowing the definition of a primary key or what a partial dependency is. That's the easy part. The real hurdle, the actual challenge, is executing the multi-step complex transformations required to take a raw database and move it into 2NF, all while under intense exam time pressure. So many students know the theory perfectly well, but they completely fail to translate that into the rigid, step-by-step logic the exam explicitly demands. And that perfectly sets up our next segment. Section 2, Core Principles and Theory. Or, honestly, a better title would be What Examiners Actually Want to See from You on that paper. Let's establish the rock-solid foundation that top-scoring students use to build their success. When we weigh superficial breadth against analytical depth and connected conceptual understanding, we are literally looking at the exact difference between merely passing and truly excelling. The academic benchmarks for 2NF absolutely require logical, highly structured reasoning. If you just superficially memorize the fact that 2NF removes partial dependencies, you are going to struggle, big time. Top-performing students, on the other hand, exhibit a connected, conceptual understanding that they can fluidly transfer to totally unfamiliar database schemas. You need analytical depth here, guys, not just a broad, shallow sweep of the textbook facts. And this depth, it's proven on paper through evaluative thinking. The examiners are specifically hunting for your ability to do 4 distinct things when you're analyzing a database table. You need to consider multiple solutions for primary key assignments. You need to analyze the trade-offs of your relational design. You have to acknowledge the limitations of your normalized tables. And, most importantly, you must justify your decisions with hard, undeniable evidence from the sample data they've provided. Top-scoring candidates actively demonstrate these specific evaluative thinking skills rather than just blindly drawing out table structures and hoping for the best. So, the big question is, how do we actually get those high-level skills onto the exam paper? Well, that brings us to Section 3, the standardized procedural framework. I absolutely love this part because I'm going to show you that there is a strict, highly reliable algorithm to solving these exact normalization problems. You don't have to guess. Let's walk sequentially through the exact 5-step procedural framework you need to use when tackling any 2NF question. Step 1, deconstruct the question. Ask yourself what dependencies are actually present here. Step 2, extract the relevant data and attributes from whatever messy tables they throw at you. Step 3, select your analytical framework to test for those tricky partial dependencies. Step 4, execute your analysis with clear, unmistakable notation showing exactly how the tables are going to split. And finally, Step 5, present your verified, shiny new relational database using the correct computer science terminology. Following this exact sequence creates a highly systematic, beautiful answer that examiners just love to give marks to. Now, to really power that 5-step framework, you need to lean heavily on algorithmic thinking. This involves the step-by-step decomposition of the unnormalized data, picking the appropriate data structure selection for your newly created tables, figuring out the efficient implementation of the relational links, and doing rigorous testing to verify absolutely no data gets lost in the transition. This algorithmic approach guarantees you aren't just, guessing where attributes go based on a gut feeling, you are systematically and methodologically processing the 2NF problem. Welcome to Section 4, Top 3 Examiner Warnings. This is where we shift gears a bit. We're going to analyze direct, unfiltered insights straight from the Cambridge Principal Examiner reports. Trust me, this is incredibly valuable data. It's basically a roadmap of what not to do. But before I just hand you the answers, I want you to really think about this for a second. Where do you think students lose the most marks in 2NF examination questions? Just pause and consider where you usually get stuck when you're doing practice papers. Is it identifying the composite keys? Is it the structural logic? Or is it just the sheer exam pressure making you blank? Okay, here is the data directly from the grading floor. The top 3 mistakes are as follows. Number 1, confusing cause and effect. Students very often mix up what attribute dictates a dependency versus what is the actual result of that dependency. Number 2, forgetting to check boundary conditions and edge cases in the sample data they provide. You have to look at the data. And number 3, and honestly pay close attention to this one because it's fascinating, answers are not specific to the context given in the question. Let me be clear. Examiners hate a generic pre-memorized textbook answer. You have to apply your 2NF knowledge to the exact database scenario they give you, whether it's a student enrollment system or a retail inventory system, if you don't use their context. An otherwise great technical response gets entirely derailed and you lose the points. And just like that, we have arrived at our final and, frankly, most important section of the day. Section 5, the method mark strategy. Guys, this is the ultimate safety net for your exam score. Please, if you take nothing else away today, burn this examiner alert into your memory. Students lose vital marks by not showing they're working out. Hiding your procedural steps, doing all the dependency logic entirely in your head, and just writing down the final normalized tables at the bottom of the page is the single biggest mistake you can possibly make. The method, the journey you took to get the answer, is just as important to the examiner as the destination. To guarantee you actually capture those marks, you need to visibly apply this deconstruct, solve, evaluate pipeline right there on the paper. Visually identify the given information, like underlining the primary keys. Clearly break the problem down into logical steps so the examiner can read your thought process. Solve the dependencies systematically. Check your new tables for reasonableness to make sure they make sense in the real world. And finally, make justified recommendations. By putting this pipeline directly onto the physical paper, you are effectively proving your connected conceptual understanding step by step. You're leaving a trail of breadcrumbs that leads straight to full marks. And this quote right here brilliantly illustrates exactly why that matters. Even if your final answer is wrong, method marks can save you. Just think about the profound relief in that statement. You might make a tiny, silly arithmetic error, or maybe you misinterpret one tiny piece of data at the very end of a 20-minute question. But if your logical sequence, your method, is clear, structured, and sound, the examiners will still award you points for the process. You can literally pass the question with a wrong final answer. So I want to leave you with this final provocative thought. How will you adapt your exam strategy to guarantee you capture every possible method mark? Because the next time you sit down with a past paper, I don't want you to just aim for the right answer. I want you to aim to construct the perfect, bulletproof, step-by-step argument that leaves the examiner absolutely no choice but to give you the grade. Thank you so much for joining me on this explainer. Get out there, apply these frameworks, and absolutely master that 9618 paper. You've got this.